Yes. So if someone's not here, they can watch on Google.
So if we talk, they can hear?
Yes. All right, so we are going to start learning systems of equations. Now, there's a couple of different ways you can actually solve systems of equations. So we're going to learn each of those ways. So you need to know how to do each way to solve these systems of equations. So on your test, when we get there, you will have to do the systems of equation a certain way, and then you can pick your favorite and do the rest of them. Okay? Because you're probably going to like one way more than the other, and not everybody's going to like the same way. So we're going to learn them all, and then you will have to know how to use each one, but for the majority, you will get to pick your favorite way. What? There's 3. All right, so this is part 1. The first way to solve systems of equations is by graphing. Graphing. System of equations are just 2 linear equations. You know those things we've been solving and graphing since we got back from Christmas? When you have 2 of those, they are called systems of equations. So like right here, this is a system of equation. This is a system of equation. Wherever they have a solution is an ordered pair. Now, ordered pair is an X. This is an ordered pair where you have X and Y. So if they only have one solution, it is given in an ordered pair. So the first thing we want to do is to make sure both lines are in slope-intercept form. What is slope-intercept form, class? Y equals mx plus b. So that's the first thing. So if it's in that form, you can go on. The second thing we want to do is to graph both lines using the slope and the y-intercept. What does slope stand for? And what letter? M. And what is y-intercept? B. Good. So if you need a reminder, write slope for M and y-intercept for B. So wherever they intersect at one point is going to be the answer. So on example number 1, here are 2 equations. I want us to graph those just like we've been doing. So let's break it down and just look at one at a time. So let's look at the top one. What is the y-intercept? 5. That's where we begin or start. So let's go up to 5. 1, 2, 3, 4, 5. So what's our slope? 1. But can I go up anymore? No. So we need to go negative, negative, because what's a negative and a negative make? Positive. So I'm going down 1, over 1. Okay, connect your points. Draw a line. Good. So our first one is done. But we have a second equation we need to graph. So here's the second equation. We do need to, yes. What is the y-intercept for the second equation? 0. Good job. There's not a y-intercept, so that means we start at 0. So our slope is -4. Now remember, if there's not a number under -4, you can write a 1, so you can use rise over run. So we need to go up 4 over 1 because it's a negative slope. You could also go down 4 over 1. So once you have both of those points, go ahead and connect the dots. These two lines only intersect at one point. So I want you to find out what that point is as an ordered pair. So you need to go -1 and then up 1, 2, 3, 4. So our solution to these systems of equation is -1, 4. You only have one solution, and that is it, because they only intersect at one point. Huh? You did learn this before?
Yes.
Okay. Is number two in slope-intercept form? Yes. So I want you to graph both of those equations.
Did you get the right?
All right. So we have graphed these 2 points. Now we want to write what their actual solution is. They only have one solution. And as I was walking around, a lot of you were getting it correctly. So they intersect at -2, 3. Okay, there's only one point. And it was -2, 3.
Yes.
Okay, so what happens if they don't intersect? Well, look down. Or it could be, okay, good. Y'all are on the right track. So look down here, in case you have forgotten. Systems with no solution. So you can write that as NS, no solution. So they don't, this is when they don't cross. So if it is no solution, if the graphs are parallel, so the graphs are parallel, but the y-intercepts are different. So, let me draw you an example. If you have y equals 4x plus 1 and y equals 4x minus 7, those are the same slope, so they're parallel, but the y-intercepts are different, which means that this solution, or this equation system, does not have any solutions. Okay? And we're going to do an example. What? Yes, they have to intersect at one point to have only one solution. There's another scenario. So there's 3 scenarios. They either have one solution, they are no solution, or they have infinitely many solutions. Remember when we called that IMS?
Yes.
Infinitely many solutions.
My teacher last year told us how to spell it out.
I don't care if you put IMS. Okay? This occurs when the graphs are parallel, so they're parallel, and the y-intercepts are the same. So basically, this happens when they are the same exact equation. Same slope, same y-intercept. Let's do an example. First of all, are both of my equations for number 3 in slope-intercept form? No, not the second one. So how do I put that in slope-intercept form? Divide by 5. So this one is correct. This is your second one should be y equals 1 over 5x plus 3.
Wait, they both have the same? No.
Do they have the same slope?
They're infinitely many.
Do they have the same slope? Do they have the same y-intercept? Let's still graph it. So, start at where? 3. Start at 3. Your slope is 1 over 5. So rise 1. I'm rising 1. And I'm going over 5. Rise over run. Down 1 over 5. Okay, graph the second one.
It already is.
It's already there. So if I graphed it, wouldn't it just sit right on top of it?
Yeah.
So you're going to have how many solutions? Infinitely many. Infinitely many. So this one was IMS, or infinitely many solutions. Okay.
When you're recording, does it hear our voice?
Yes.
Okay.
Okay? That's not always a good thing. Okay, let's graph number 4. So you go to positive 2 to graph number 4. Rise 3 over 1. Or you could go down 3 over 1. So this was the first equation. Also graph the second equation. It's a shame they have so much in common. They will never meet. Someone wrote that on their justification question. Yeah, it made me really happy. Good job, Dylan. So, one solution, infinitely many solutions, or no solution? No solution.